Hi everyone, Val from FleaSystems.com here. Welcome to Workbench. Now, I'd like to start off this video by saying thanks to those of you who received my FPGA development boards in the past. I hope you found your boards useful or helped advance your understanding of the wonders of FPGA technology better, and which brings me to the topic of today's video. In my spare time, I've been working on a new FPGA development board, one that was inspired by a recently released product, namely the Raspberry Pi Zero, which you've probably all heard about, or most of you, if not all. On my previous FPGA development boards, I used the Mark X02 FPGA. This time, however, I'm using the brand new ESP5 series FPGA, also from Lattice Semiconductor. The ESP5 has way more logic resources than the previous X02 and is more capable. Anyway, here's a picture of the new board, which I've decided to call the FleaFPGA Ohm. Now, Flea Ohm has the same overall board dimensions as Raspberry Pi Zero and uses a compatible GPIO header, but unlike Raspberry Pi Zero, I've also added 3 analog to digital converter channels to the same header. And also I've made the digital video out and USB host ports full-sized, none of this mini or micro rubbish. I didn't like the idea, wanted to keep the board cost as low as possible. And now the Flea Ohm can also be used either standalone or as an expansion hat for Raspberry Pi, but it really was more designed to be standalone, and it has both external and internal JTAG programming options, which is great if you want to do real-time debugging of your FPGA using an external JTAG interface. It's also got 32 megabytes of SDRAM, it's got micro SD, it's got an SPI config ROM, which also has some room for user flash as well. And yeah, also I've added provision for a Wi-Fi interface, but and that's in the form of a ESP8266 chip. It's not a module, it's just a chip. Now, I haven't yet decided if I will include that in the final version. I've also got under development a Flea Ohm with DDR2 RAM, as opposed to the current prototype which has SDRAM. Now, for the rest of this video, I would like to show a demo of my Flea Ohm board in action. Hopefully the first of many. Now, yeah, so without further delay, let's move on to our demo. Okay, so on to our demo. Now, I thought we'd have some fun with the Flea Ohm board. So for today's demo, I've decided to do a retro computing example for Flea Ohm. So I've ported and tweaked a version of the Minimig HDL project to run on the ESP5 FPGA. Now, some of you may be asking, well, what's a Minimig? Well, Minimig is an amazing project created by Dennis Van Wieren to re-implement in hardware the iconic Commodore Amiga home computer from the late 80s and early 90s. The Amiga itself was created by Jay Miner. For its time, the Amiga was an outstanding computer that was ahead of its time when it was first released, and in some respects still holds up well today. So I thought, how cool would it be to get this great project running on my Flea Ohm board? Now, in the build that I've used for the Minimig, it implements a machine with up to 68020 CPU, 4 meg RAM, ECS chipset, 2 virtual floppy and hard drives, so it's pretty much an expanded Amiga 500 or 600. Now, among the tweaks that I have made to Minimig was the inclusion of digital video and audio out routed through the HDMI cable. Now, some of you who may have used an Amiga before may be asking, well, where's the mouse? Well, I did take the liberty of adding a mouse port to the GPIO header on another Flea Ohm prototype, and there it is there. Now that was successful, but we'll have to show that in another video. Anyway, we've got ourselves a boot screen beckoning us for a boot disk, so let's give it one. I'll take the keyboard. Now with the Minimig, we we can use a pop-up on-screen display to select our virtual disk images from the SD card. So we'll start off. Okay, so our first program we'll try is a game called Xenon 2 by the Bitmap brothers. Now, I remember playing this game back on the PC, in the PC back in the day when I was in high school, and yeah, it was an amazing game for its time. Vertical scrolling, shoot 'em up, and anyway, the sound of the Amiga version of Xenon 2 was a big surprise to me compared to the PC version, which still sounded pretty good for a beeper. Okay, so going to have to play this with a keyboard, folks. I could have wired up some joystick ports to the GPIO header, but I never got a chance to do so. So, alright, let's play a game. Okay, here we go. You're gonna love that parallax scrolling. Very smooth. Oh, the sounds sound pretty good too. Oh, it doesn't sound good, it sounds great. Okay. Alright, so anyway, that plays really well, and it's hammer time. So anyway, that's Xenon 2, folks. So now let's try another program. This time we'll do a multimedia demo. So it's not it's not an app or a game. It's just a straight up demo program. Multimedia demo, so pick the right one, there we go. Reset the Minimig. Now, countless computing demos have been created for the Amiga over the course of many years now, and this demo now that we're seeing is one of the better ones in my opinion. It's called State of the Art by the coding team Spaceballs. And much to respect to these programmers on the Amiga and all platforms who push the hardware to the limits and beyond with amazing coding tricks and feats with their roto zoomers and textured cubes and all sorts of wonderful stuff, and garage shading and just very cool stuff. So if I have time, one of the things I'd like to try is getting AGA and more Fastmen to work on the Flea Ohm with the Minimig. These are all Amiga terms, and there appears to be enough room on the FPGA for both, from what I can see. Groovy. Visual morphing looks pretty cool too. I like that. That's one of the things I particularly like about this demo. So there you have it, folks. Best of yesterday's technology brought back to life with modern technology. The Flea Ohm. Success. Well, that's it for today, folks. I hope you enjoyed the video. Now, for those of you who may be interested in Flea Ohm, I am considering doing a run of boards like I did for my past FleaFPGA Uno and Classic boards. But first I want to make some tweaks and fixes to the current Ohm board design. I will definitely keep you guys posted on that. Now, before I go, I want to give a shout out to my mates over at our local Amiga computer user group here in Melbourne, Australia. Guys, many thanks for your ongoing support and friendship, including encouraging me to do this video. Okay, that's all I have for now. Please keep an eye out for any future updates. Until then, happy experimenting. See ya.